Okay, so let's, from here on, everything we're going to build will be part of that cluster that we saw at the beginning. So we start with, actually let me jump back to that picture to refresh everyone. So we're going to start by building out this backend, and all it's going to be is a really simple JSON API that will just return a JSON object. And we're going to do it with Haskell because Haskell. But I don't want to spend any time on Haskell, so I'll just copy and paste this to helloapi.hs. Okay. And then before we use Nix to build it, I want to show sort of a quick way that I sometimes use to get a GHC environment with some packages without having to use Cabal or Stack or anything like that. So if we evaluate this expression and pass it a packages argument that includes Haskell packages that we're interested in, we'll get a Nix shell that has not only GHC, but all of those packages available to it. And we don't have to use Cabal to exercise any of them. So this Haskell program uses ASON, it uses Scotty, and it uses all the underlying things like text and other libraries. So if we try to just run this with GHC, it's not going to work without those things. But if we fire up a Nix shell and put in this magical incantation, it should work. So now I'm running a Nix shell, and I've put this package specifically in my environment. And this package, when I highlight this, this is a function that builds a package, and it takes this argument. So now I should be able to compile hello API.
Quick question, so do you do GHC with packages that also brings in GHC, but like a default version or something?
Right. Right. Again, just like GCC, you have to decide which version you want.
But you could you also just specify it in the packages list, like packages.ghc version whatever? Or must it be?
Well, not in this particular expression, because GHC with packages is a function that takes a list of packages that it also includes, like links or however that works. So I've compiled it. I can run it. If you all try to run this, we're all going to get, yeah, so somebody already beat me to it. That's fine. So you should be able to go to infostructure.com port 3000 and see something, /greeting. Let's try it. 3000, greeting. I may have that port closed. Yes, I do. So I won't bother with this, but I'll just show you because it's interesting. So this is the configuration of the server that you guys are on. And I've made no firewall permissions, which means it's letting 22 through and nothing else. So yeah, 3000 is not going to work. Yeah, you could do it locally. Anyway, let's move on. So that's a quick way to use GHC without any other tooling. Let's use a Nix expression to build this thing as an actual derivation. So I'm going to cat this out to helloapi.nix. And this is pretty similar to what we saw before. We have a few more bindings in our let expression. This one is just what we had on the command line. So we're just, for convenience, we're making paths a function that takes a packages argument and returns a list of these 3 packages from it. GHC is a result of calling this function with that argument. And then source is just our current directory, which is our home directory. Normally, you wouldn't do this in a real production Nix expression because the contents of the source of this directory can change at any given time, and that's not very functional, right? So there are a lot of built-in functions like that you can see on these 2 links, and they give you ways to fetch source from GitHub or from a Git repo or from a zip file or whatever. And they include arguments that you have to supply that say, I want to fetch this Git repo and I want it to be this git SHA, and I expect it to be this Nix SHA. And that will make sure that you're downloading the right version of that source code and always building the same thing. And also that gets cached. But for this workshop, we're just telling it, use whatever's currently in source. And so it will have to rebuild it every time.
Paths is a function, right?
Paths is a function.
And so packages takes a function.
Right. Yep. So otherwise, this is pretty much the same. We make a directory to put our output. We have to create a temp directory because GHC wants to make some compile time artifacts. And so we stick those in that temp directory here. Then we point it to our source. So it's in source, which is dot or slash dot helloapi.hs, and then we give it an output. And so if we run nix build on this, we should get a bin/helloapi with our Haskell Web Service. Also, one thing to point out, because we'll use this later, this thing returns a JSON object with two values, greeting and hostname. So greeting is always hello. Hostname is the hostname of the server. We're going to use that later when we scale out our backend and we want to see that we're actually round-robining between our backends. Okay, so let's deploy this, finally. We're going to deploy just our backend, and it's going to be this much of our cluster. So we're going to be able to hit it directly through HTTP. Okay, so now we're building an actual NixOS configuration using Nix. So once again, let me paste this, and then I'll walk you guys through it. So I'm going to put this in backend.nix. And this much of this file is a NixOS configuration. So if you were running NixOS on your server and you wanted to build it directly, you would have a configuration file that contains what I've highlighted. So it's a function that takes a bunch of stuff and then sets a bunch of things. If you go into, on slide 4, there's a link to the NixOS manual. And then at the top, if you click on options, this will let you search through all of the NixOS options, of which there are very, very many. So anything you can think of to configure your system, whether it's networking or hard drives or packages or systemd services or whatever, those will all be in here. So for example, we are configuring our allowed TCP ports on our firewall, which NixOS just turns into some IP tables rules, I think. And then we're also setting up a systemd service for our backend server. It also has a lot of built-in stuff, so you don't always have to define your own systemd service for everything. For example, if we wanted to install Nginx, we would do services.nginx.enable equals true. And then there are a bunch of others, Jenkins, Tomcat, you name it. There's no hello world, though, so we have to do that on our own. I'm going to kind of gloss over the systemd configuration. It's not that interesting. And then finally, the result of evaluating this backend.nix produces just a set with one value. And the value is called backend, and it's equal to this big function, this NixOS building function. With Nix, so this is now a NixOps configuration. With NixOps, you produce sets of instances, basically, and everything that's not named network.something is considered an instance by NixOps. So NixOps would evaluate this and say, okay, we want to make one instance that we build using this function, and it's called backend. Although you'll note that we don't have anything in here about Amazon or VirtualBox or anything, so we're coming to that. This you can skip because you have these keys set already in your environment. But if you're doing this locally, for example, you'd want to export these AWS keys for some account that you own. Yeah?
So looking at this, the argument for that unplanned function is this set. But none of those name or those identifiers in the set are actually used in the set that you produce. So why not just ... there if you're not actually using it?
Because then if I try to reference them, oh, you're right. So I could just have ... there. I probably copy-pasted this from somewhere else in my config. But to answer your question, if I wanted to use any of those, then I would need them here. But I think you're right. We could probably just change this to ... and it would be fine.
Change what to ...
So the question is about the particular inputs that I specified to this function, and I said resources, packages, lib, nodes, and whatever. But I'm not actually using any of those in here, so I probably could have just omitted them. Yeah, it's just an oversight on my part. Okay, so we have one last thing to do before we're actually able to deploy this. We have to tell NixOps what our target environment is, which in this case is Amazon. So here's the configuration, and I threw a VirtualBox config in there just so you can kind of see the difference. Also, if you're doing this locally, you could deploy this back into VirtualBox instead of Amazon if you don't want to deal with that. So yeah, let me follow my same pattern. I'll cat this out to target.nix. And let's quickly go through it. So we have two big functions in our let expression. This is configuration for VirtualBox, and I don't want to go too much into it because we're starting to get short on time. And then similarly, this is configuration for EC2. Particularly, we've said which region we want to deploy to. We could say things like which subnet, and there's all kinds of other configuration, which you could find in the NixOps manual. And then I just have one sort of shortcut binding here called target. I did that because we're going to have a bunch of instances, and they're all going to be using this EC2 configuration. But if I easily wanted to switch all of them back and forth from VirtualBox to EC2, I can set them all equal to target and then change target back and forth.
So what exactly is that EC2 generating? Is that just commands to be run?
It's configuration. So EC2, so this reads, EC2 is a function that takes at least these inputs, and again, they're kind of superfluous. And yep, resources is being used, and returns this set, so it's just key value pairs. And it happens to have these 4 key value pairs. And that's all EC2 is doing.
So then you basically get that config, and then how do you actually, like, what ends up doing this deployment? Is that
A command, which we're about to do.
Oh, okay.
Yeah. And by the way, all of this stuff, all of these settings, we could have just pasted this directly into our backend.nix. But NixOps allows you to split configuration across files, which can be convenient because, for example, all of our instances are going to share this config. So it's nice to have it in one place. Okay.
And, what about conflicting keys? Does it take the later one?
Conflicting keys, oh, like in a set?
Yeah, if you merge.
If you merge sets, it will take one of the two, but I don't know which.
The second one wins.
The second one wins? Cool. Oh yeah, that's a good question. So the dot notation is for nested sets. So if I have something like x.y equals 5, I can say .x and get that inner set, and then .y to get the 5. Oh, I see. X equal to something else, so let's make... Oh, sure, okay. So in this case, it's actually overwriting the whole X. Yeah. That can catch you by surprise sometimes because you might think that it's merged. There's a slight discrepancy in the way that NixOps allows you to break config across multiple files, where the backend from the target.nix and the backend from the backend.nix will get merged, even if they have these similar subsets. But generally, I found that this will happen. It will overwrite, and then lose settings that you thought you had. Is there anything else? So we give our network a description. That's just so you can find it in Amazon. We're going to enable rollback, which we'll use later. And again, this is all NixOps configuration, of which there are many, many, many options. So I encourage you to look at the NixOps manual and see what's there. We're going to deploy it to the Northern California region, and this is where you might think that we're overloading or overriding the other backend, but NixOps just smashes them together. So we're saying backend, which is the same backend from before, is equal to target, which is equal to EC2, which is equal to this function, which NixOps will evaluate for us, and then add these values into our backend set. All right, let's deploy it. So we're going to deploy it by first creating a deployment with NixOps create. And we're going to name our deployment with D. So we're going to call it Nixt. And then we're going to tell it which Nix files we want to include in that deployment. If you want, you can just say star.nix. It would support that. We're going to have more and more Nix files going forward, so you might want to do that. So I'll do NixOps create, and I'll name it Nixt. And I'll say I want to include backend.nix and target. So now it's created the configuration for the deployment. It hasn't actually deployed anything yet. And we can sort of look at the status of it. We can see what deployments we have with NixOps list. And so we just have one deployment. It's called Nixt. It has 0 machines because we haven't deployed anything. If we want to dig into that particular deployment, we use info. And we say use the deployment Nixt. For the rest of the workshop, this -d Nixt should be optional because we only have one deployment defined. So NixOps will generally infer that that's the one we're talking about. So we've got 2 things in our deployment. We have Nixt, which is missing. It hasn't been deployed, but that's a key pair. That's something for Amazon. That's actually used to set the public and private key for the root user on that machine. And then we have backend, which is the backend that we just configured, and that will be an EC2 instance. Say again? Yes. When we say deploy, it will create those. So I think that's the next step. Yep, so let's deploy it. So do NixOps deploy. I'm going to try it without the -d and make sure that. Uh-oh. How do I have a quota? Yeah, well, this must be something on my AWS account. How many people have successfully deployed so far? 1, 2, 3, 4, 5, 6, 7. Okay. Does anyone know how to change a quota?
You gotta request it.
Oh man.
I stopped the mine. Try again.
Oh, that really throws a monkey wrench into this thing. Shoot. Well, I have another user where this is already running. Yeah, I don't think Amazon support is going to get back to us within a matter of minutes. Oh man, this is so disappointing. If we change the region, do you think that will?
So wait, it's like the later
Well, the goal is to have everyone running it at the same time. Otherwise, it's way less cool. Oh man, that's a bummer. All right, well, I think we're stuck. If there's no way to increase quota without a support ticket, I apologize for that oversight. It worked when I tested it with 2 people. So, yeah.
What options do we have to deploy in-house?
Okay, so right now we're deploying to Amazon. I suppose I could run this whole thing on VirtualBox and show you, but so it supports Amazon, it supports VirtualBox, it supports Hetzner, whatever that is, or you can deploy to physical machines. So like if you have a rack and you've installed NixOS on each of those, just like a bare NixOS, you can point to them by IP. Rather than so back here when we configured our target, instead of using this, you would say deployment.target environment equals whatever that particular value is, and then tell it the actual IP addresses.
They all have to be the same version of NixOS.
No, yes, because it will build it locally and then push it, and so I think it would cause problems if they were different. I don't know. That's actually interesting. I'm not sure. Yeah.
So since you can do like parametric deployments,
Mm-hmm.
can you write apps can they use the same deployment technique as the bare metal?
Yes. Yeah. So to build on your question, if you have existing NixOS EC2 instances deployed somewhere, you could deploy to them as though they were bare metal. So instead of, you wouldn't use the target environment EC2, which underneath the covers uses all of the Amazon API to provision things. You just point directly to the IP addresses, and you need to make sure that you have the right SSH access.
It's not like how many per month or something. It's like running
What's that?
instances.
Oh, you mean my quota problem? Yeah, I think there's some, there must be a limit on the quantity of, here, if I refresh this.
See numbers like 20.
I guess my account is only allowed to run 23. Oh, no, 3 are stopped. So yeah, 20. Yeah, I didn't know that. I didn't know I had to. Yeah, so, well,
It seems to be limited by region.
it's 20 people in here minus the other things that I have running.
Or we just pick.
Yeah, I think you might be able to
Yeah. Yeah, if you want to try changing the region, that might work. No, that's not going to work because I've locked down this particular credential to just deploy to this one. I hope it wouldn't work.
I think he said, no, I know. Oh, you haven't? Okay.
You're free to try, but I kind of hope it doesn't work. By the way, I will be terminating these after this workshop, so don't put anything you want to keep on these.
Will you be changing your AWS?
Yes, I will also be deleting this key at the end of this workshop.
How do you bring down after you deploy?
So you can use NixOps stop. And that will just tell Amazon to shut them all down, to turn them off, but not delete them. This is probably an AWS error. And then if you want to actually get rid of them, you can use NixOps destroy and or NixOps delete.
Another question, sorry.
Yeah.
We probably shouldn't be talking about Docker here, but I'll ask anyway. So, for example, in our company, there are some teams who release internal Docker images.
Mm-hmm.
So, irrespective of which OS we are in, even if you prefer, you're forced to use Docker. So, does it even work together?
Yes. So it works in both directions. You can run Docker within a Nix environment because it's just a Linux environment, or you can have a NixOS expression and build that into a Docker file, and now it's a Docker image. I've never done that, so I don't know how that works, but I know it's a thing.
Okay.
Yeah.
Speaking of Docker, like when I tell my friends or whatever about Nix, we're talking and stuff like that. Typically, someone goes like, "Why would I want to use Nix if I already use Docker? Like, what's the thing?" And I can't put my finger on it. Like I don't know enough about Nix to say why should I use this instead of that or some combination. Maybe someone can clear that up.
So I'm not really a Docker expert, but I think there's some situations where Docker is better and some where Nix is better. Like if you want to have an image that you can send around to people and you know that it will be the same image, maybe Docker is a better answer. If you want to be able to take advantage of this store and have resources cached and different users using the same thing locally, maybe Nix is the right answer.
So Nix is going to give you way more reproducibility than Docker is because your Docker tag that you point at is mutable.
That's a good point.
So every single layer that ultimately makes up that Docker image can change up underneath you if you point to something in the middle and it's higher tree change. So by doing this, you're essentially running a snapshot of stuff and have a much more stable thing. You can have that be your single layer of your Docker image that is added. That is the Docker image going to pass off to the ops team where they then do say like Docker. Okay.
So let's do one more and then move forward. Yeah.
What are the best practices for doing configurations of different versions of, say, like a web server? Does it support multiple configs per version at the same time?
What's the context? Are you talking about a server?
Let's say I'm running two different versions of Contact.
Okay.
I want different configurations for each. Are those
So you wouldn't be able to use the Tomcat, the built-in Tomcat configuration on NixOps. You'd have to define your own systemd services for those. And that's just because of the way that those get interpreted by NixOps.
So you're saying it's not support? There's no per package config support?
No, not like that. Okay, well, so maybe we can turn this into more of a demo and less of a workshop. If everyone who has it deployed can just stop theirs, I'll kind of step through this and show you what it would look like. Yeah, so it's NixOps stop, and then that should be enough. Mine's going to blow up. I will.
Yeah, I'm trying to do something that's destroy.
You can do destroy or whatever. I'll do it for you after this. Okay, so how many are actually running? Oh, okay, thank you. So now if I do NixOps deploy, yay. So it's starting. There are several NixOS AMIs, which are the base images for Amazon, and it's using one of those to create a new EC2 instance that's size t2.nano. That's in our config. It waits for Amazon to assign it an IP. Once it has an IP, NixOps can actually SSH in and then start building or transferring Nix artifacts. And so that's what's happening right now. It just SSH'd in. So it's building everything that we've defined in our backend. So there's nothing really here except for instance configuration, but in our backend.nix, we have helloapi.nix, which itself has all that GHC stuff with making a temp directory and using Scotty and ASON. And then it also has a systemd definition. And so this should finish fairly quickly because there's not too much for it to do. It builds it on the guest, for want of a better term. It doesn't build it on the remote node. It builds it locally, and then it pushes. Yeah. So for us, that means it's building on the big server that we're all SSH'd into, and then it will push it out to the little one that is getting created. Okay, so now it's finished building everything, and now it's sort of restarting services as necessary. Okay, so now if I do NixOps info, I can see I've got a backend and it's up, and it even has an IP address. I also have a key pair that was used to do it. So I should be able to go to this IP address, and we opened up port 3000 in our backend config. So I should see, oops, it's actually /. Oh, bother. Oh, I wonder if port 3000 is actually blocked from this Wi-Fi. No, the security group's definitely good.
I have problems like I can't connect to IRC no matter what port I use. So.
Okay, but that's fine. We won't need to go to 3000 directly anyway. If we were outside of this university network, this would show us our JSON response. That's not a Nix problem. That's just the Wi-Fi is locked down. Okay, so now my backend is deployed. So let's move on to the front end. Sorry, this is no longer interactive. I know that's a lot less interesting, but maybe I'll just go quickly and then we can go back to discussing things. So our front end, actually, let me go back to the big picture. So what we're going to have is a bunch of backends, and those are running a JSON API, and a front end, and that's going to have some static HTML that's calling the JSON API. So here's our static HTML, and all it does is make an XHR, and it sends it to /API/greeting, parses the result, and then just prints it on the body. So I'm going to cat that to index.html. And now I need to make a build for it. So there's nothing really to do. It's just a file. So our build is merely copying that from the source to the store. So I'm going to call this hello static. And if you go back to the beginning of the presentation, we're now at this point. We built everything up to this line so far. Okay, so there's my hello static, and what's next? Okay, so when I deploy this, this is what we're going to have. We'll have 2 IP addresses, one for the front end, one for the back end, and we can hit either of them over HTTP. Okay, so I have a Nix expression for building the HTML, but I don't have a Nix expression for the NixOS server that is the front end, and so that's here. And it's pretty much the same as what we just saw. The main difference is we're not creating our own systemd service. We're just using the built-in Nginx that comes as part of NixOS configuration. So we say we want to enable Nginx, and the Nginx config is the following. So it's just a server that routes us to our index.html. So let me paste that to front end. And then the last thing I need to do is actually 2 things. I need to tell NixOps that I have this new Nix file that I want it to care about. So I'm going to modify my deployment and add frontend.nix. So NixOps modify is just like NixOps create, except it's for an existing deployment. Okay. And finally, I've defined the front end NixOS configuration, but I haven't told NixOps how to deploy this thing. So we want to give it the same EC2 config as before. So we're going to do that by opening up target.nix and just copy this line. So we want the front end to use the same settings that are in target, which is EC2, which is this thing. So our backend and front are both going to be t2.nano instances in US West 1. Okay, and then now I can just redeploy. NixOps deploy is idempotent, so if I run this and I haven't actually changed my config, nothing will change on the server. So just like before, it has to create a new EC2 instance for the front end, which will be this box. And then it's going to install Nginx. It's going to build the front end, which means copying that HTML file, and then it's going to configure Nginx to serve that file. And that's all based on this config. It's also going to allow port 80. So hopefully this should actually work. So we'll give this a minute. Yeah.
So some of what we've seen here looks like it can do things that Ansible and other things can do. Is there still a need to use Ansible and other things, or NixOps can take over pretty much whatever the case is?
The question is about sort of how this compares to Ansible. Ansible is much more feature complete, I would say, than NixOps. So NixOps is missing a lot of things, in particular for configuring Amazon. The environment that we're deploying to, we haven't told it anything about VPCs or subnets, and so NixOps will just deploy to your default subnet. But generally, you probably wouldn't want that. Like in this cluster, you'd want your proxy to be public, but your other stuff to be private, like inaccessible to the web. In that case, you'd have to set up the VPC ahead of time, and then in your NixOps config say, oh, use this subnet for the proxy and use that subnet for the other stuff. So there's definitely more manual config but an advantage that Ansible lacks that Nix has is Ansible has to sort of SSH in and check versions of things.
I didn't necessarily mean Ansible. It could be Salt, or it could be anything.
Okay, sure. In terms of maturity, NixOS has probably fewer features than fill-in-the-blank DevOps tool. But what it lacks, it makes up for, in my mind, in terms of its declarative nature and pseudo-reproducibility and so forth.
Can you work at all with, say, legacy systems that are not yet in NixOps? Ubuntu and all of this?
If you could install NixOS on those machines, yes. But if they're, like, you couldn't use NixOps to manage a bunch of Ubuntu servers, for example. Okay, so our front end is deployed. So if I go to my EC2, we have a lot of stuff that's stopped. But we should have some stuff that's not stopped, including the front end, which what I should have done is put the username in the network description, and then we'd know who had deployed each of these. But anyway, one of these is my front end. Yeah?
How do you reference for instance, the IP addresses of other servers in configuration?
We'll get there, and that's the next step, because the proxy will have to do that to route to the right servers. So let me do NixOps info to see what we've got. We have a backend. Here's its IP, same as before. We have a front end now, and here's its IP. And since that's running on port 80, we should be able to actually access it, but it's not going to work, and I'll show you why. So it's just a blank page. And in the slides, the reason is that XHR is trying to get /API/greeting, but there is no /API on the front end server, so it's just a 404. Yeah, /greeting is running on the back end, so now we're going to need our proxy to make that request go to the right place. Okay, so now we're going to put a proxy in front of these two. They're all still going to have public IPs because of this AWS configuration issue, but that's okay. As long as we hit our proxy, everything should work. So this is kind of funny. This is a Nginx configuration, but it's written as a Nix expression, and that's because of your question. Nginx needs to know the IP addresses of those two machines so that it can route front-end requests to the front-end machine and back-end requests to the back-end machine. So we pass in nodes, which is a field that NixOps manages, and it gives us access to each of our instances. So here's front-end, and front-end has a config, and config has a networking, and networking has a private IP v4. It also has a public, but we want this to be sort of, I guess, production-like. So it'll actually use the private Amazon IP that's internal to that VPC or that subnet. The rest of this is pretty much the same, except we're using proxy pass. Instead of serving anything directly, we're just forwarding the request onto one of the two machines based on the URL. And this is just Nginx configuration. You could use HA proxy or something else if you wanted to. The reason we're using Nginx here is because in a couple slides we're going to add HTTPS support, and that's been integrated really well with Nginx. So it'll go out to Let's Encrypt and request a cert and then install it in Nginx, and then we're good to go. So I'm going to copy this into nginxconf.nix. And go forward. And again, we have a Nix expression to configure our proxy NixOS machine. And all we're doing is enabling Nginx and pointing it at the config that we just wrote. This is one other thing that we didn't learn about sets before. This syntax here, inherit nodes, is the same as saying nodes equals nodes. So it just sort of passes that along. So if I wanted, it's not really useful here for one value, but if I wanted to pass along 10 different fields, I don't want to say A equals A, B equals B, C equals C. It's kind of annoying. I could just say inherit A, B, C, and so on. So I'm going to paste this NixOS configuration into proxy.nix. And finally, we need to tell NixOS that our proxy is going to be the same EC2 kind of configuration. So I'll just copy this line and change it to proxy. Okay, so now I should be able to do a deploy. And while that's building, let's go forward. Oh, nope, see, I screwed up. So I forgot to modify my deployment and include that new proxy.nix. So this is going to really mess things up. Let me fix that. So because I added one line to target, NixOps knew that I wanted a new machine, but it didn't know anything about the NixOS config of that machine because I hadn't added proxy.nix. So it started to create the instance, and then I quit. And then I added that to my deployment and redeployed. Yeah? So in terms of safety of interrupting this, it's pretty safe, but it's not bulletproof. There can be problems. For example, the key pair that NixOps is using to SSH into these instances, that could change for various reasons that maybe NixOps is not aware of. Excuse me, and that's because Amazon allows you to associate key pairs independently of what NixOps is doing. So you could go in and change the key pair, and then this would suddenly not be able to deploy. I suppose as long as you get the instance deployed and the key pair is good, interrupting a deployment after that shouldn't really be problematic, other than you're you might not finish deploying what you want to. But I guess the important thing is all this is atomic. So it either all happens or all doesn't. So if I said, upgrade to the latest Tomcat, deploy, and then I hit Control-C halfway through that, it wouldn't be in like a halfway state. The only thing that would be in a halfway state is some stuff would be cached in my store because it had downloaded and maybe started building some things, but no config changes should have been applied. So now we should have a proxy, a front end, and a back end. So if I do NixOps info again, there they are. So I'm going to grab the proxy IP address and go back over here. And so it says hello from backend. Oopsies. And if I look at the network traffic and refresh, you can see it's getting slash, which automatically gets routed to the front end node and returns the HTML. That HTML then creates a XHR that gets /API/greeting, which happens here. The proxy routes that to the backend serves it, and then it gets rendered. So we've got our 3-node cluster so far. Okay, now let's add DNS support. This is just a 1-line change to my proxy, because that's sort of my front end for maybe to overload that name. So I'm going to tell NixOps, for my proxy node, I want you to configure the host name to be this. So this is just, and get the environment variable user, which in my case is student2.infunstructure.com. So I just made that 1-line change, and I'm going to deploy again. And this will just use the AWS API to create a Route 53 entry, which this user is allowed to do. Yeah?
Configure ELB with NixOps as well?
You can't configure an ELB with NixOps. As far as I know, you'd have to set it up manually and then tell NixOps where it is.
Sorry if you answered this. So all of your deployment info is being stored locally.
Mm-hmm.
So if you had like a team of DevOps, you would something.
Yeah.
Right.
Yeah. So NixOps, all of my, if I do a list, all this deployment, and if I do info, all of this info is local. It's actually local to my user. It's under .nixops or nix-ops or something in my home directory. So if I want to use this on a team, there are ways to do it. None of them are beautiful. There's a way to export 100% of the configuration to JSON, and that's NixOps export. And that has it has everything you need, all the IP addresses. It also has sensitive stuff like private keys. Yeah, like there's a nice private key. So yeah, in a team environment, the way that I've done this is you do an export and then you version control it if you're comfortable having keys there. Or you do all of this on like a central server that everyone can go into, or a continuous integration environment can run from. And then you make sure you're backing it up because you don't want to lose those keys. Or otherwise you lose access to those machines.
Can you have your own Nix repo server and
Mm-hmm. Yep. Yeah, you could mirror it and point your channel to that mirror, or create whatever.
build everything yourself?
Yes. I don't know how to do that. Something like that. Yeah, Nix has this build system called Hydra that I know absolutely nothing about. So anyway, hopefully the DNS propagation has happened, and I can change this thing to student2.in infunstructure.com. And it works, woohoo. Okay. Scaling out. So let's imagine that we want to scale out our backend because it has high load and it's really non-performant. All we have to do is edit 3 files. So I'm going to go into my backend, and this is my NixOps configuration. So I say, NixOps, I want an instance called backend, and it's configured by this. So I'm going to tell it I want 2 more instances. I'm just going to paste this twice, and I have to give it new names because this is a set, and keys have to be unique. So I'll call it backend 2 and backend 3, but they're all equal to this same NixOS config. I'm going to step on the gas because we're running out of time, and I really want to get all the way through HTTPS. So now I've configured my 2 new nodes. I have to tell them that they're also EC2. So I'll edit my target. And so backends 2 and 3 will also use this same target config. And then finally, I have to tell Nginx how to use it. So, So here's where I configure my Nginx backend, and I'm just going to tell it, hey, there are 2 more servers. Here are their IP addresses. And Nginx will round robin requests between these 3. So let me do a deploy. And now it's firing up 2 new backend instances. And you can see these things are interleaved, so it's all happening in parallel. Any questions while this goes?
How would you do a graceful deployment? You have 6 servers and you want to upgrade the version 1 to 2, take the amount of rotation.
If you want to deploy only certain servers, there's a -- include or -- exclude on the NixOps deploy, and I think that'll also work for stop and destroy and delete as well. So you could do it kind of manually that way. If you wanted to do some other kind of scaled rollout, you could easily, just like I added those 2 new machines, you could go into your config and add the new ones and then deploy, and your old ones won't have changed, but the new ones will. And then maybe take the old ones out when you're ready and redeploy. That's a little bit more resource intensive because it's spinning up new things.
Is there any, like you're running this locally and switching out closure, all those code out, right? But typically you'll run an auto-scaling group and like listen to the launch configuration, right? So it's just cloud edited or whatever on the machine, right?
Possibly,
so,
but I don't know anything about auto-scaling.
Well, I'm just saying because you have to be there when failures happen.
Right. Right. Yeah, this is very manual. Like I'm very explicitly saying I want 3 servers, and if all 3 go down, they're down. Like 3 more aren't going to pop up. So yeah, like if I wanted this to be high availability or have like good resiliency, I wouldn't just do it all manually. I would use an ELB, and I would use some kind of auto-scaling solution that Amazon has already figured out. So all 3 backends should be deployed now. So I'm just going to go back to the front end, student2.infrastructure.com, and refresh. So hello from backend. I'm going to refresh again. There's backend 2, refresh again, backend 3. So if I keep refreshing this, you can see that it's round robining those requests to all 3. So I've now got a proxy, a front end, and 3 backends. Oh yeah, let's do rollbacks real quick before we do HTTPS. So if I ask, maybe I'm interested in all of the deployments I've ever done. So I'll say NixOps list generations. And I've deployed 5 times, and the current one is number 5. So I can do NixOps rollback, and I want to roll back to deployment number 4, and that was before we added the 2 extra backends. So that's how fast it was. This is some of the benefit of not clearing your garbage too soon. It's very quick to deploy. So now if I refresh the front end a bunch of times, it's always back end, right? Because the old Nginx config has been applied. Those 3 nodes are all still running because I haven't destroyed them or stopped them, but they're not being used for anything. Although it could leak your EC2 budget a little bit. So I'm going to roll back forward, back to number 5, so that we can get our 3 backends, and it's done. And so if I refresh, there they all are. Okay, one last thing. We've got about 5 minutes, just in time. So I'm just going to kind of breeze through this. I'm going to completely overwrite my proxy config. The interesting stuff here is this security.acme. This is in the NixOps manual. This is stuff that's built into NixOps. It has an Acme client, so it knows how to go out to the Let's Encrypt Acme server and request a cert. At that point, Let's Encrypt will try to hit student2.infrastructure.com to make sure that I own it before it gives me a certificate, which should work. And then Nginx will reconfigure itself, install the real certificate, bounce itself, and then we should be good to go, pending any DNS propagation. Which shouldn't be a problem because it's already working. So I'm going to overwrite my entire proxy.nix. And at this point, all the files I showed you under that /source directory, that's the point where we are right now, as soon as I get past this step. Oopsies. Bear with me. Okay. Okay, that should be it. Okay, so all I've really done, I know I went through that really fast. I just told NixOps, I want you to use Let's Encrypt, and by the way, use it with Nginx, which it knows how to do because somebody's done all of the hard work for me. And I'll just redeploy, and assuming I didn't have any paste errors, it should be fine. And so now it's going to create a self-signed cert in Nginx. It's going to request a real certificate from Let's Encrypt. They're gonna come back and verify that all the right key exchanges validate my identity or whatever, and then they'll emit the real certificate, which Nginx will install. Nginx will then restart itself to use the real cert, and then hopefully it should all work. Okay, so it's done. Now at this point, it might look like it's done, but it's failed because it's still trying to go back and forth with Nginx. And usually that happens because of DNS propagation. So like if we had gone right to this step before ever doing any of the DNS stuff, this probably wouldn't have worked and we'd have to wait a few minutes for it to retry. But I'm feeling lucky. So I'm gonna put HTTPS here, and it works. So now we've got just in time. Oh yeah, ignore the database. We've got everything but the database. So traffic comes into our proxy over HTTPS. The proxy then routes over HTTP. Notice we didn't have to do any certs here or here, which is kind of handy. Although we have to be okay with private traffic being unencrypted, but I'm fine with it. The next step, and I'll just show you since we have about 3 minutes. If we wanted to add a database, we would tell NixOps through resources.rdsdb instances, and that's just an Amazon configuration option. We'd say, I want a database. I want it to be in US West 1. I want it to have this ID. I want it to be a t2.nano, et cetera, et cetera. I want it to have some passwords. And then in backend.nix, we would probably want to tell, let's say our Haskell server went to the database to get something. We can get the endpoint for the database, the URL, from Nix by saying .endpoint. And so in my backend.nix, in that systemd configuration, I could just add an environment variable. And now Haskell just has to look up db URI, and then it can go to the database. So that's about it. Are there any other questions?
So with the NixOps stuff, when you come to the database, is figure out the graph, so the database is up, so it source the value, set the environment variable, propagate to the backend.
I don't quite understand.
So if you update your backend config, so you want the URL to come from property placeholder and database backend.
Right.
It's essentially orchestrating, making sure that the database is up, so it can get the URI.
Yes. Yes. So when I specify this and then NixOps evaluates that, it'll actually make an AWS call to say, hey, what's the endpoint for that DB? AWS says error, it's down, or it says it's 123.456, whatever, and then that'll get assigned to that environment variable. So if for some reason it changed, like somebody went in and bounced to that RDS instance manually, this would break because your Haskell server would have the old environment variable. Any other questions? Yeah.
Is it possible to use this to sort of deploy locally to like containers, like assuming you want to have this?
Yep. So in my target, if I just changed this one line and then redeployed, it would create a bunch of VirtualBox instances.
Not containers per se, but VirtualBox.
Yep. And unfortunately, we can't do that on this machine because it's an AWS instance, so it's already virtualized. So this would actually fail. Any other questions? Well, sorry about the resource limit, but you should be able to just mechanically follow back through this with your own, either with VirtualBox or your own keys, and it should just all work. But I'll be around for the whole conference, so grab me anytime. I can set you up with some keys just to play around with for a few minutes, and then you can experiment to your heart's content. All right, thank you.